Let us now discuss the solution of a problem from the section 3-dimensional geometry. The question is based on the concepts of the direction cosines of the given two straight lines. This question has appeared in the joint entrance examination main held on 27th June 2022 in the first shift. The given question is, if the two straight lines whose direction cosines are given by the relations L plus M minus N is equal to 0, 3L square plus M square plus CNL is equal to 0 are parallel, then the positive value of C is, we are given four options. Option A 6, option B 4, option C 3, option D 2. We are given two straight lines, and the direction cosines of these two straight lines satisfy the equations L plus M minus N is equal to 0 and 3L square plus M square plus CNL is equal to 0. Further, it is given that these two straight lines are parallel, then required to find the positive value of C. That is the given question to us. We now discuss the solution of the problem in detail. Let the direction cosines of the given two straight lines be L1, M1, N1 and L2, M2, N2 respectively. So we have given the direction cosines here of the two straight lines. Agreed. And given the direction cosines satisfy these equations L plus M minus N, that's the first equation, and 3L square plus M square plus CNL is equal to 0, that is the second equation. We first take the first equation L plus M minus N is equal to 0. From this we get N is equal to L plus M, and we substitute the value of N in the second equation. So substituting in the second equation 3L square plus M square plus C into, for N we have written L plus M into L. Now C into L, CL square. So when you simplify 3L square plus CL square, that will be 3 plus CL square plus CLM plus M square. So 3 plus C into L square plus CLM plus M square. Agreed. We divide throughout by M. Then we get 3 plus C multiplied by L plus M whole square plus C times L plus 3 plus C multiplied by L by M whole square plus C times L by M plus 1 is equal to 0. What is this? It is a quadratic equation in L by M. It's a quadratic equation in L by M. We continue in the next slide. So we have this equation, which is a quadratic equation in L by M. Now so far we have not used the fact that these two straight lines are parallel. We have not utilized this parallel property. So given that the given two straight lines are parallel and the direction cosines of the first are L1, M1, N1, for the second is L2, M2, N2, and these two straight lines are parallel, means L1 by L2 is equal to M1 by M2 is equal to N1 by N2. Okay, we take the first two equalities, two ratios we take. So L1 by L2 is equal to M1 by L2, M1 by M2. That implies L1 by M1 is equal to L2 by M2. That means these two are equal. What are these? These must be the solutions of this quadratic equation. And further, these are equal. This implies this equation 3 plus c into L by m whole square plus c times L by m plus 1 is equal to 0 has equal roots for L by m. What are those equal roots? L1 by m1 and L2 by m2. So what's the condition now to have the equal roots? This implies it's the discriminant capital D is equal to b square minus 4ac is equal to 0. B in our case coefficient of L by m, c square minus 4a, the coefficient of L by m whole square, that is 3 plus c into the constant term 1. So when you simplify, you will get c square minus 4c minus 12 is equal to 0. And the factorization is very, very simple, and it will be c minus 6 into c plus 2 is equal to 0. So this will give rise to the values c is equal to 6 or c is equal to minus 2. Look at our question. We have to find the positive value of c. Minus 2 is negative, so reject it. So the positive value of c is 6. That is the answer to this question. Let's look at our options. Our answer c is equal to 6 appears against option A. Therefore, the solution for this given question is option A. The answer for this given question is option A. So that is the detailed discussion of the solution of the problem, which is based on the direction cosines of the given two straight lines. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.